So I work for Sandy, but I'm actually based in the Centre for Invasion Biology at Stellenbosch University. What I'm talking about today is something that came up at a workshop we had on tree invasions in Argentina last September. And not everybody listed here are authors on this paper, but it's good campus for some of these people, so it's blame them. So the idea really is that if you look in conservation science, there's a very good process that links research into management and legislation, the IUCN Red List process. And there, the unit is they're wanting to predict the time to predict the time to extinction, I should read. And there they're wanting to put things in different categories on the basis of the time to extinction. And I'm sure you're all well aware of the different categories. We already heard some of that earlier. And one of the things that actually in that Red List process is it stimulated an incredible amount of basic research. And I think if we compare that with, so here again we've got the criteria that are legislative, and there's management implications of each of the criteria, but that's based on underlying metrics to measure, for instance, the estimate of the current population size, the extent of occupancy, and how those things are changing through time gives you an indication of whether things are a threat. Down the bottom, the criterion A is an unfavourable quantitative analysis, where you can actually do a robust estimate of extinction risk, population viability analysis. Obviously, for invasions, it would be great if we understood the mechanisms behind the invasion, and then we could really do a full cost-benefit analysis and be able to say this is how much it would, all the different management options. But we're not going to get there for hardly any species. We really do need something a bit simpler to work with. And the situation on innovation science, we've basically got expert opinion. We've got quite a few lists. 100 of the world's worst invasive alien species. It's basically a matter of opinion where people say we don't like this one. And also there's a lot of policy and theoretical frameworks, of course, but they don't really talk to each other. So to give you some examples of this, there's a very nice paper where the IUCN is trying to develop indicators for this sort of thing. And the indicators that they came up with were a number of invasive alien species per country, how those, whether they're listed, have some impacts on red listed species, and then international and national policy adoption. And of course, you're probably all sitting there realizing, and we've already seen that there's significant problems with listing the number of invasive alien species. That depends on how much effort's been put in, and there can be errors. Clearly, that impact is only one measure of impact, and then the amount of policy documents really doesn't necessarily, unless you're trying to get rid of paper, it really doesn't reflect the amount of actual on-ground management and moving towards management goals. On the other side, we've got some quite, I think it's been the trend for quite a while. You can publish a framework in invasion biology and you get it published in a nice journal and everybody claps. But these sort of things don't, at the moment, go into really trying to get to impact management. And this is one recent one from Tim Blackburn, and it's really based on the ecology, trying to understand survival, whether things are reproducing, how they're spreading, and that gives you some way of categorizing biologically the different types of invasion into this scheme A to E. What we were thinking that one of the things is, because we don't have that time to extinction as the unit. So the unit we were thinking would be useful here is the concept called invasion debt. And we've got something where, I'm not going to go through it here, and it's still work in progress, but we're really wanting to propose that quantifying invasion debt might give you a routine as a unit to measure. So that's composed of introduction dynamics, but also if we stopped all new introductions to the country, there's going to be a large number of invasive species which will naturalize over time, so there's going to be a species level invasion debt. clearly species are going to spread to new areas, so there's an area-based depth, and then there's clearly the impacts are going to change over time, so there's an impact element to that. We've got some equations underlying this, but clearly we need to get some metrics that people can actually measure to get an idea of what these things would be. This brings us back to trees, and I borrowed a photo from Brian Van Vilken of where actually, some of you driving here would probably have driven through areas like this where you see these horrific pine invasions. Of course, there's quite a lot of existing data. Marcel Romanek and Dave Richardson recently published an update to a list of invasive trees and shrubs, and that's ones where they've got a really good confirmed record that it's invasive in a biogeographical sense. But if we look at the real situation, we want to go beyond that yes, no, invasive one. We want to get some idea of what the dynamics are. So if you think of this is perhaps not a real situation, a very idealized situation of a range and trees within that, what are the sort of aspects we want to measure in this case? We've actually already sort of talked about some of these ones, but we were thinking there are 4 basic elements that we want. We want to be able to look at the status, we want to be able to look at the abundance, the spatial extent, and the impact. And clearly for all 4 of those, we want to see how they're changing through time. Looking at potential status, population growth rates, spread, and threat. So I'll just go through each one of these and we'll try and propose some sort of metric to look at. For status, we've actually got the Tim Blackman scheme, which gives you a letter to describe what type of where it is on the introduction, naturalization, invasion continuum. Of course, this is site-specific. And what we suggested was there's a table that you can fill in. So, are there seepings of vegetative offsprings present? Are they only under the canopy? Are they further from the canopy, or are they quite distant? And then filling in this sort of information gives you insights into how you would categorize the invasion. Potential status is clearly a little bit more difficult. One of the simplest ones we can do is the suitable range size from a species distribution model, just getting you an idea of how much area the species could potentially occupy. For abundance, with a couple of simple measures here. One of the things that we thought was to look at the number of management foci that you'd need to look at, or number of populations. Clearly, in the nice idealized case, this works lovely, but we've just seen some pictures where those populations are fairly continuous, so we'd need to get something extra here for those sorts of cases. And we've just been hearing about that compressed canopy area, which is essentially area of occupancy, and then it's obviously linked straight back to the IUCN category. On all these cases, the population growth rate is then how these things over time, with the important proviso that you need a time series to do this. Spatial extent, we've already heard some things on this, and then you can either do spatial extent in terms of each population individually, or draw a sort of alpha hull polygon around the whole lot. And that gets you to the extent of occupancy, again, reflecting back on the IUCN categories. Spread, clearly you'd also need the time series. For impacts, this is where it starts getting really difficult, of course. One of the things that is readily available and is widely used is the Australian Weeds Risk Assessment Protocol. We're not suggesting to use it here for risk assessment per se, but it's a very good source of collating data because it forces you to answer a series of questions, and then if you give the reference ideas of what's known about the species and what sort of impacts you might expect, and whether it's allelopathic, unpalatable to grazing animals, and so on. And I don't know if there's, I suppose parasitic trees, we could talk about some of the umbrella tree that Leslie, it's not parasitic, but it's the same, the stranglers, I guess, would be the group. So in terms of the thinking of threat, this is where it breaks down almost entirely. So Marcel Romanek came up with this, and I think it's actually quite a good, simple way of looking at things. if you've got a tree and you're assessing the risk it's posing to a particular area, there's two simple questions that we can look at to see, to really rank it. The first one, is it taller than native vegetation? And the second one, does it have the traits of a transformer? So is it a nitrogen fixer? Is it going to change the fire cycle? These sorts of questions. And clearly, if you answer both, yes to both of these, this is something that you really do want to worry about. Well, actually, you never want to worry, but yeah, you need to worry. So bringing this back onto that sort of idealized system, we've got the status. In this case, it's invasive across a wide area. You've got the potential range size, this sort of pinkish colour. You've got the number of management foci, which is say 4. The compressed canopy area might just be 10 hectares, but the extent of occupancy is likely to be much greater, say 6,000 hectares. And then you've got your quantitative impacts reviewed in strain and risk assessment. And clearly this goes into a sort of example of species report. So one way of thinking immediately from this thing is to think of the list that Marcel Romanek and Dave Richardson went through, and we're trying to move that data onto the next level. So the conclusions, these metrics would also provide very useful headline statistics for policymakers. They do in some cases link directly to assessments of management that provide useful baselines. They have got some ecological basis behind them. And crucially, it's going to start allowing those comparisons between regions where there's quite a few papers where we want to compare alien species lists in one country and another country, and actually so much of the work on that is about the different methodologies as opposed to really how things are functionally different. Of course, these are deceptively simple measures. Well, perhaps not that deceptive. We've just had a few talks. It's incredibly complicated to estimate some of these things for a lot of species. But we're sidestepping that issue in a yes. So a comparison with the red list. So thinking back, how far have we got to that ultimate goal of lists for invaders? We think we've defined some of the key features of invasion, though we'd be welcome to suggestions. And we've got some basic metrics that describe elements of these. We think potentially going forward a unit to think about is invasion depth, but clearly we need to have some sort of cut-offs and categories in a similar way. But one of the important things is that in terms of way forward, we obviously need to develop and test this process. And a red list might never be achievable for invasive species. It might be it might simply be something that cannot be done. But I think the process of trying to unpack it can potentially be really useful in terms of forcing us to think about certain things in particular ways. One of the other things, looking back to Vernon's talk on grasses, we started off with trees, and it's nice and easy relatively. But there might be key differences when you think about grass invasions or some of the aquatic invasions that these metrics really don't apply. And obviously one of the beauties of the IUCN scheme is it works for salamanders and syringa. Actually, I should have thought of what salamanders, syringa, and spiders or something like that. And that's where we are at the moment. Well, that's actually Argentina, but it's got a similar problems. Invasive pines coming in and disrupting these beautiful Araucaria woodlands. Thanks.